Hello, dear students of grade 5. This is your teacher, your science teacher, Muhammad Qasim. I miss you so much. As I always say, you are the best students in the school. And today, inshallah, we will know what are the outer planets. We have talked before about the inner planets, and it's our time to know what are the outer planets. Before this, we have a small note about the size of these planets. Do you think they are smaller or bigger? Of course, they are bigger. In the front picture, you have seen the surface of Jupiter changes every day. What do you think that caused these changes? Why the shape of the surface of Jupiter changes every day? What do you think that caused these changes? Maybe storms, maybe moving rocks, maybe space rocks that hit the planet, and so on. Before this, let's make a comparison between the inner and the outer planet according to the size.
How are the sizes of the inner and outer planets different? Observe carefully. Observe the sizes of the inner planets. Compare them to the sizes of the outer planets.
Now you know that a globe represents Earth, but what if I were to tell you that this radish could represent Earth too? What if I then told you that this head of lettuce represents Saturn? How is lettuce like Saturn? How is Earth like a radish? The answer lies in relative size. Now let's take a look at these foods. Each food is a model of a planet in our solar system. Here we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Now, the purpose of this model is to show the size of the planets in relation to each other. For example, you can see that the radish, Earth, is small in comparison to the cantaloupe, Jupiter. You can also see that there are 3 planets smaller than Earth. By looking at these models, we can tell many things about the size of the planets in relation to each other. But are there things we can't tell as well? Models are helpful tools we can use to represent larger things in the natural world, like the solar system. But in order for a model to accurately teach us about the structure and functions of the solar system, it is helpful for it to be built to scale. That basically means that if the sun is 10 times bigger than the biggest planet in real life, the model of the sun should be 10 times bigger than the model of that planet too. So for example, if this cantaloupe represents Jupiter, and the sun is 10 times larger than Jupiter, we could represent the sun with a giant pumpkin. So our model of food representing planets can show us the relative sizes of the planets and which one is closest to the sun and which one is farthest away. But is this model able to tell us everything there is to know about the solar system? When something is so large and complicated as the solar system is reduced to a tiny scale model, there are certain limitations. We cannot know detailed information about the planets, such as how high the mountains are or how deep the oceans are. If you added a person to this model in the same scale, you'd have to use a microscope just to see the model person. In this video, we saw that making a model of the natural world is helpful, but it also has limitations. Make a model of your house using modeling clay. What information are you able to show? In what ways are you limited?
Until next time,
Our solar system is made up of 8 planets. There are 4 inner planets and 4 outer planets. The outer planets are much larger than the inner planets. These planets are Jupiter, Saturn, Uranus, and Neptune. The outer planets are often called gas giants because they don't have clearly defined rocky surfaces. Jupiter is the largest planet in the solar system and appears to have bands of color. Its atmosphere contains mostly hydrogen and helium. Saturn is the 6th planet from the Sun. Saturn is very large and has many orbiting rings. Like Jupiter, Saturn's atmosphere is mostly hydrogen and helium. The 7th planet, Uranus, has an atmosphere that contains hydrogen, helium, and methane. This planet is a blue-green color because of a thin cloud of liquid methane covering the entire planet.
As you heard in the previous videos, there are differences between the sizes of these planets. As you see in this activity, you have some models for the bigger planets or the outer planets and the inner planets. As you see here and here, they are the outer planets. What about these small balls? They are the inner planets. We have also chart here that shows us the comparing diameters, imaginary of course. If you want to make a model, you're going to make the Mercury diameter of 5 millimeters, Venus 12, Earth 13, Mars 7, because they are small planets. What about the outer planets? Oh wow, 143, 121, 51, and 50. So they are much larger than the inner planets. So where are the outer planets? Of course, they are beyond Mars. They are after Mars. Beyond means after. Jupiter, Saturn, Uranus, and Neptune, they are known as the outer planets. So when I ask you what are the outer planets, you have to tell me the four names of them. Jupiter, Saturn, Uranus, and Neptune. Very well. The outer planets are much larger than the inner planets. They are much larger than the inner planets. They don't have clearly defined surface, which means it's not clear if they have surface or not. They just a lot of storms, dust, and other things because they are gaseous planets. Okay? We only see the atmosphere of them. So for these reasons, these planets are often called gas giants. So what can we call them? Gas giants. Very well. However, they have liquid inner layers and solid cores. They have liquid inner layers and solid core, unlike the inner planets, which have a liquid melted core. These planets have different cores. They have solid cores and they are not molten as the inner planets. Each of the outer planets has rings of particles and many moons orbiting it. What do you say? Many moons? Yes, many moons. Not only one or two. Sometimes they may reach to 64. 64 moon? Yeah. Very well. Look at these two different planets. The inner planets have solid crust from the outside and a rocky surface, then a rocky layer, then molten layers, then very hot molten layer inside the core. What about the outer planets? They have gaseous surface and they have solid cores inside them. They have solid cores. It's not molten. So when he asks here about compare and contrast, write some similarities and differences between the inner planets and the outer planets. Can you solve it? Well, I need you to write at least three. Three differences and three similarities between them. Well, this is everything for today. Thanks so much. I hope you have enjoyed. Bye.